Okay, so in this video, we want to do a quick review of the trigonometric function called the sine function. So if you recall, we start with a right triangle. Let's label the angle at the base theta, and we have three sides of the triangle. Let's call them ABC. And if you recall, with respect to theta, these three sides have special names. A is called the adjacent, B is called the opposite, and C is called the hypotenuse. And by definition, sine of theta is the opposite over the hypotenuse. So it's B over C. Now, the sine function has a key property, and that is that it remains the same for any similar triangle. Now, triangles are similar if one is a multiple of the other. So suppose we multiply all of the edges of this triangle by k, where k is some positive number. Assume, for argument's sake, k is smaller than 1, so we get a slightly smaller similar triangle. So now the edges are ka, kb, and kc. And so let's see if sine of theta is preserved. Sine is, by definition again, the opposite side over the hypotenuse. So it is kb over kc. The k's of course cancel, and we are left with b over c, just as in the original triangle. So why am I mentioning this? Well, if the sine function is preserved for any similar triangle, it would make sense to take the simplest possible such triangle. And the simplest choice is that of a right triangle where the hypotenuse is equal to 1. And there's something very interesting if we make that choice. Suppose that we have a right triangle that is similar to the original triangle, where the hypotenuse is exactly equal to 1. Now let's look at what happens to sine of theta. Well, if you think about this again, by definition, the sine of theta is the opposite over the hypotenuse. But if the hypotenuse is 1, the length of this over 1 is just the length of this. So when we take a right angled triangle with a hypotenuse of 1, the sine function ends up being simply the height of the triangle. So the sine function becomes essentially trivial, geometrically, once we have a right triangle with a hypotenuse of 1. The sine of theta, the angle at the base, is nothing but the height of the triangle. And now we want to sketch the graph of sine of theta, as theta varies from 0 to 2 pi. So once we complete a full revolution, but what's interesting is, if you look at a segment of length 1 and have it complete a full 2 pi revolution, this will trace a circle of radius 1. So it's very natural to first inscribe this triangle inside of a unit circle, centered at the origin. And when we say unit circle, we mean a circle whose radius is equal to 1. Let me try and keep this for now. So we have a circle of radius 1, so the intercepts are 1 and negative 1. And again, we pick a right triangle with a hypotenuse of 1. So this fits perfectly in our unit circle. The hypotenuse being 1 ends up being the radius of the circle, and again, sine of theta is the height of the triangle. So now let's sketch the graph of sine of theta in the theta y plane, again as theta goes from 0 to 2 pi. And there are 4 quarters of the circle, so we'll go in sketching the graph 1 quarter at a time. And if you look at the endpoints, so this will be theta is 0, then theta is pi over 2, pi, 3 pi over 2, and 2 pi. So we have pi over 2 right down the middle, pi, sorry, and pi over 2 here, and here 3 pi over 2. So let's look at what happens to the height of our triangle, the sine of theta, as we go from theta being 0 all the way up to theta being pi over 2. And again, by default, when we say increase theta, we always go counterclockwise. If we said decrease, so go in the negatives, then we would go clockwise. And this is nothing but a convention. So now imagine bringing this triangle down to the x-axis where theta is 0. So at this point, the height is equal to 0. The triangle has no height, so the sine of 0 is equal to 0. Now as you increase the angle from 0 to pi over 2, then the height of your triangle will increase all the way up to 1. So as you increase theta from 0 to pi over 2, sine of theta will increase from 0 all the way up to 1, where it attains its maximum value. What happens from pi over 2 down to, or up to I should say, pi? Well, again, as you move the triangle along the circle, as you increase theta, the endpoints will move from here all the way down to here, so the height of the triangle will decrease from 1 all the way down to 0. Once theta reaches pi, you have again a horizontal segment. It has no height, and so at pi, sine is 0. So the sine function will go from 1 all the way down to 0 between pi over 2 and pi. Now what happens in the third quarter when the angle goes from pi to 3 pi over 2? Well, again, the ray will go from here to here, the hypotenuse of our triangle. If you look at the corresponding height, it will go from 0, and you see it will get larger and larger, but now in the negative y values, and all the way down to negative 1. So it goes from 0 down to negative 1 as the angle goes from pi to 3 pi over 2. So the smallest value of sine is negative 1. And now we've reached the fourth and final quarter. So as we now increase the angle from 3 pi over 2 up to 2 pi, the height will start at negative 1. And now it will get less and less negative. So it will increase until we reach 2 pi, where once again the ray, the hypotenuse, is on the x-axis. So again we have no triangle, so it has no height, and so the sine will achieve a value of 0. And now we have the graph of sine of theta. As theta ranges from 0 to 2 pi. And we can stop there because, again, if you keep going, well, the argument will repeat itself. It's the exact same geometric figure. So the sine function will continue as a wave for infinity. And it's the same for negative values. You simply pick this up and copy it here, and the sine would keep going as a wave forever. So you now have a very simple way from, again, taking a right angle with hypotenuse 1, then the sine of theta is the height of the triangle, and as you visualize the height changing as the angle changes from 0 to 2 pi, you have a very quick way of obtaining the graph of sine of theta. And to complete our discussion of sine, we will now mention its 5 key values. We already have 2 of them, and we'll only mention them in the first quadrant. As for the others, you can sort of fill in the holes. So if you start, well, the 2 key values that we have are at 0 and pi over 2. So the sine of 0 is equal to 0. Then at pi over 2, the sine is 1. So those are key but very simple values of sine. And the sine function has three other key values in between 0 and pi over 2. And those are at pi over 6, pi over 4, and pi over 3. And they are the following. So sine of pi over 6 is equal to 1/2. The sine of pi over 4 is equal to root 2 over 2. And the sine of pi over 3 equals root 3 over 2. And that's it.